We're going to review the little bit of gravity that we did in fall semester and then go into what we did not talk about in fall semester, which was the plug and chug stuff. So first, the equation for universal gravitation was this one. Fg equals G m1 m2 over d squared. In terms of some concept stuff here, let's label what is what. M1 and M2, these are the two masses. And for there to be a force of gravity, there needs to be two masses and a distance between them. Any two objects that have mass have a force of gravity or a force of attraction between them. Fg means force of gravity. That capital F, the main letter, tells us what variable, and the subscript tells us which specific one. So force of gravity. Now, in terms of some of the concept stuff that we talked about in first semester, which is all we really touched on, with masses, since masses are on the top, these are directly related, and distance is inversely related. What this means is that as mass increases, the force of gravity will also increase. So the more mass an object has, then the more the force of gravity will be. Inversely related to distance means that as the distance between them gets larger, then that means the force gets smaller. The further apart they are, the smaller that force will be. Now, because of Newton's third law, the forces between the two masses, whether or not they have the same mass, will always be equal. So forces are equal but opposite. And so, for example, there is a force of gravity between you and the Earth. The Earth pulls on you with exactly the same amount of force that you also pull on the Earth. That's what Newton's third law tells us, equal and opposite. Now, the one thing we really did not talk about last semester was this G value, this big G. What we said was that it was a constant, and that's all we cared about. Now we care about what the value is. It is a constant, so every time you plug numbers into this, you will need to use this number. It is not 9.8. This is capital G, not little g. Capital G has the value 6.67 times 10 to the negative 11, a very small number. This value is why the force of gravity in general is so weak. You cannot feel the force of gravity between you and the person closest to you. You cannot feel the force of gravity between you and your pen or pencil. And that's because if you take these two masses and you divide them by the distance between you and multiply it by this extremely small number, you will get an extremely small number. Hence, it rounds to zero. Now, the reason why we can feel gravity on Earth, though, is because the mass of the Earth, one of those masses, is so large that it's able to overtake that 6.67 times 10 to the negative 11. And so that is why you cannot feel the force of attraction between you and your pen and pencil, but you can feel the force of attraction between you and the Earth. All right. let's do some examples. For our first example, we're going to look at the force of attraction, which would be the force of gravity between you and your friend. So you, 50 kilograms, that is a mass, and your friend, 60 kilograms, that is the other mass. Honestly, the first one I come to, I make 1, and the second one I come to, I make 2. So M1 and M2 are sitting 0.3 meters apart. That is a distance. What force of attraction exists between you? So let's start with the equation. Fg equals G M1 M2 over D squared. All right, do we have capital G? Yes, we do. It's right here. 6.67 times 10 to the negative 11. Anytime you see capital G, you have to plug in. 6.67 times 10 to the negative 11. M1, which we said was 50, and M2, which is 60. And all of that is divided by 0.3 squared. Now, you will notice that I put parentheses around everything. And whenever we get to more digits that have scientific notation, it is going to be imperative to be able to do that in a calculator. The calculator will only do what you ask it to do. And so you have to be very explicit about what you put in the calculator. Because of that, I'm going to use an online calculator and show you how to do this. Okay. 6.67 times 10 to the negative 11 times 50 times 60 divided by 0.3 squared. And if we hit enter, we get a very, very small number. Now, because of the way calculators work, some calculators are coded to give you the expanded form like this, and some calculators will give you the scientific notation instead. So, depending on what calculator you are using to see this particular answer, I'm going to write it in both forms. So one of the answers would be 0.000022233. And that would be newtons. If you're using a graphing calculator, it might instead give it to you in scientific notation. But those are exactly the same number. Which one is correct? The one that your calculator gives you. All right, now let's do another one. You are now standing on the surface of the Earth, and we want to know the force of gravity between you and Earth. So you, M1, Earth is M2. The radius is your distance. The force of gravity is always from center to center of the objects, and so the force of gravity between you and Earth is between you and the center of the Earth. Now, some questions might see this force of gravity, others might use weight. Both are the same. They are both the force of gravity between an object and a celestial body, so like a planet or a moon. So Fg equals G m1 m2 over d squared. Fg equals, still that same number, 6.67 times 10 to the negative 11 times m1, which is 50, times m2, which is 6 times 10 to the 24. And that is all over 6.4 times 10 to the 6th squared. So now we have a bunch of scientific notation in here. Therefore, we have to be very careful about using those parentheses in the calculator. Now, this is also a good time to show you why we actually feel the force of gravity on Earth. This 10 to the negative 11 is extremely small, but look at how large the mass of the Earth is. It's 10 to the 24th. So like I said earlier, it overpowers that 10 to the negative 11. All right, let's plug this in. 6.67 times 10 to the negative 11 times 50 times 6 times 10 to the 24th divided by parentheses 6.4 times 10 to the 6th, close parentheses, squared. So make sure you look very carefully at how I enter this into the calculator. And the answer is 488.5. All right, the last thing you'll have to be able to solve for is going to be for a mass. You will not need to solve for distance. You'll have to solve for force and mass. All right, let's see. Two objects feel a 1.48 times 10 to the negative 9th Newton force of gravity. Newtons is a force, so that is Fg. See, between them when 3 meters apart. That is our distance. If one object has a mass of 10 kilograms, that's m1, what is the mass of the other? So m2 is our question mark. So here's our equation again. And now we have the Fg. And again, for completion's sake, I'm putting all numbers in parentheses. So G, 6.67 times 10 to the negative 11. M1, which is 10. M2, which is our unknown, all over 3 squared. Now, a couple of methods for solving this. Some people were taught algebra where you move each object individually, but I've noticed overall with students that it tends to be taught where you combine all of this first. So you do 6.67 times 10 to the negative 11 times 10 divided by 3 squared. So let's put that into the calculator. All right. So open parentheses, 6.67 times 10 to the negative 11 times 10 divided by 3 squared. And we hit enter. Now see how this time, because the number was so small, the calculator gave us scientific notation automatically. So that's what I was talking about. Some calculators do it earlier than others. So this is the combined number. Let's write that one down. 7.41 times 10 to the negative 11. And then we still have M2, and then we have 1.48 times 10 to the negative 9. Now there's only one number to move, and since it's times M2, we are going to divide both sides by that 7.41. That's an 11. Go. Now let's put that in the calculator, and we'll get our final answer. So open parentheses, 1.48 times 10 to the negative 9 divided by 7.41 times 10 to the negative 11. Again, making sure we have parentheses around everything, and we hit enter, and we get 19.97. And that is our final answer. And mass is measured in kilograms. All right, that is it for gravity. Let me know if you have any questions.